So in our Cambridge endorsed book for A-level physics, we have 4 equations of motion, and 2 of them are given on the formula sheet. So these are the 4 equations that you need to memorize. I should say 2 of them need to be memorized because the other 2 are given on the formula sheet. Which 2 are given? Uh, Third one and the last one. These 2 are given. I would say the first one is from the very definition of acceleration, and the second one is the formulas displacement equals to average velocity into time. So let us talk about the derivation of these. In order to derive this equation, in order to get to this expression, let us recall the very definition of acceleration. Acceleration equals to change in velocity divided by the time in which the velocity changed. Now this thing can also be written as v minus u divided by t. Let's say the initial time was 0, then we can write it as simply t, because the difference from that time would be t only. T minus 0 would be t. So what do we do afterwards? Because we have this thing, a equals to v minus u over t. Although we know that this is the formula of acceleration, we could have started from this step, but once we're doing the derivation, we try to extend the steps. We try to break it down to each and every step. Now I'll cross multiply 80 on this side, and 1 would be multiplied to the other side, and then you shift minus u, 80 plus u equals to v, which is just the same thing as v equals to u plus 80. So the checkpoint, the important takeaways are: try to break it down into steps and list all the mathematical equations which are used, and just follow the sequence. Then we know the next one. Let's take a look at the next one. All right, so one of the expression that we know is displacement equals to average velocity into time. So if the change in velocity, let's say the change in velocity is constant, the velocity is being changed with uniform acceleration, the graph will look something like this. Initial velocity was u, let's say the final speed or the final velocity is v, and all of it took place from u to v. The velocity changed in t seconds. Then we can say the average velocity, because the initial is v, u, final is v. What is the average of these two? Well, we find the average by adding the two quantities and divided by 2. So what we can say is v average equals the two velocities added divided by 2. So if I plug this one in the expression, I'll get to this thing. There you go. So we need to get to this one. Whatever we have done so far, we can use those equations. So I'm going to write those equations over here. These can be used as a prerequisite. One of them is v equals to u plus 80. And the second one that we are done with is s equals to v plus u or u plus v divided by 2 in all of it into t. So let's take a look at that. So we're done with these two. So what I'm going to do is I'm going to insert the value of v from here all the way in this equation over here. So I'll write the second one first. Let me write plus v, u plus v. So this is the second one. What I'm going to do is, instead of this v over here, I'm going to insert this value. I'm inserting v equals to u plus 80. So now the equation will look something like this. So instead of v, I'm going to write u plus 80. Everything else would be written as it is. Let's do some mathematics here. U plus u is 2u. 80 as it is. Divided by 2 as it is. Times t as it is. I can multiply t with everything inside the brackets. So 2ut plus 80 square, all of it divided by 2. So we have two terms. Both of them are being divided by 2. That means we can write first term divided by 2 separately and second term divided by 2 separately. We can do some cancellation here. This 2 and this 2 would be cancelled out, and you'll be left with this thing. And this is exactly what we had to derive. So s equals to ut plus 1 over 2 80 square. And what are the quantities used in this one? S is the displacement, u is the initial velocity, t is the time, 1 over 2 is a constant number, a is the acceleration, and t is once again the time. Let's take a look at the last one. So once again, all the equations that we have done so far can be used as a prerequisite. So I'm going to rewrite the equations that we are done with. V equals to u plus 80 and s equals to v plus u, half of it, into t. What do we do afterwards? I'm going to make t the subject. If I make t the subject, it would look something like this. If you rearrange the first one, you make t the subject, it would look something like this. So what I'm going to do is I'm going to write the expression for the average velocity once again, this one. And this thing was being multiplied by time. In the next step, I'll insert the value, or I'll insert the expression for t over here. So t equals to v minus u over a. So I can write it this way. So instead of t, I can write v minus u over a. What do we have then? 2 and a at the bottom on this side, they're being divided on the right side, but on the left side they'll be multiplied. So now you need to expand this um, using the simple mathematics, or you can use the expression as well. You can use the identity as well. Instead of writing v plus u plus v, you can write the first one as v plus u. 5 plus 2 or 2 plus 5. The answer would be 7 anyway. Now if you could recall the expression, which was a plus b times a minus b, that equals to a square minus b square. So what do we get here? V square minus u square. And if I rearrange, make v square the subject, okay, then we have the next thing. In the questions, there are certain conditions that needs to be fulfilled before you could use any of these equations. How many of those? The 4 of them. In order to use any of those equations, these two conditions should have been fulfilled. The first one is that for the object for which you're applying the equation of motion, the acceleration of the object should be uniform. This is one of the conditions. Acceleration of the object should be uniform. The other condition is you should be able to replace speed and velocity, or interchange speed and velocity, which means object should be traveling in a straight line. So sometimes they ask you for the conditions as it is. So these are the two conditions which needs to be fulfilled for the object to be traveling for which you can apply the equations to calculate anything. Let me give you another thing. What do we have here? The second one. S equals to ut plus 1 over 2 at square. Or let's get on to this one. In many of the cases, this equation is used like this. And what is that case? Well, that is the case when object was initially at rest, when the object was not moving initially. So the initial velocity would be 0. And this is mostly used in free fall motion. The simplest case for that equation could be an object. You have an object over here that falls to the ground. It was initially at rest, and the distance covered, or the object was dropped from a height of, let's say, 100 meters. The object was initially at rest. It is dropped from a height of 100 meters. Assume that it travels with uniform acceleration. It travels in a straight line. So we can say, let's say that there is no air resistance, hence the acceleration would be uniform. The question could be, how long does it take for the ball to hit the ground? Or in other words, you need to find the time. So t needs to be found out. How do you do that? You see, you have only a single thing over here. That is the displacement, 100 meters. Now, since it's the free fall motion, so the acceleration would be used as the acceleration of free fall. It can be used as 9.81. If the object falls vertically downward, we assume that the acceleration would be plus 9.81. Mathematically, we can use plus 9.81. If we throw it upward, we can use it with the negative sign. Or the convention can be reversed also. But for this one, because the displacement will increase this way, so we say when the object falls downward, the acceleration would be positive. So what do we have? We have only a single quantity, displacement. We need to find the time. You insert the value of s, 100. You insert the value of a, 9.81, and you